My name is William, and I'm going to talk to you about predicting player churn in free-to-play online games, specifically from the mobile app store. So just the project proposal, a bit of background first. So free-to-play games gain revenue through advertisement, in-app purchases, and downloadable content. Now currently retention is a huge concern in the online games market, reportedly ranging from 20 to 50% per month, and if you compare it to the telecommunications market, which is roughly 2 to 3%, you can see there's a huge room for improvement there. Now, with the large amounts of user data available, your company can increase player retention and revenue per player through predictive modeling and analysis. Now, the aims of the model would be to develop a model that is not game specific, but a generic model for all free-to-play games. It would classify players based on whether they are churned or not churned, i.e. active, and then it would predict when a player's behavior is likely to lead to a churn. Now, incidentally, this can also be used to predict future churn rates and inform game development, but that's a side issue. Now, why is this useful? Now, it allows your company to target and incentivize those players before they churn, increasing potential for monetization. And so again, why does it matter? So in economic terms, the profitability of a retention campaign can be expressed as a function of the churn prediction model performance, given the following parameters. We won't go into that, but essentially it equals profit. So how will we do it? So we're going to use, as I mentioned before, binary classification, so churned and returning players, or active or non-churned. So we're going to use features that are universal among free-to-play games, so no game-specific features. So we have temporal features such as number of sessions, number of days since sign up, current absence time. We have granularity features, so average play time per session and average time between sessions. And because the free-to-play games are so dependent on the in-app purchases for monetization, we have 4 virtual economic features, which are premium user flag. So it's pretty much just saying, has the player made an in-app purchase? Predefined spending category, number of purchases, and average spending per session. Now we run all these through a decision tree classifier for 2 reasons. Firstly, off previous work, the decision tree has produced the most accurate results, particularly independent of game content or genre, and we're using the universal features above. And it also provides simple and intuitive explanations of observed behavior, allowing your company to respond rapidly to those players that are likely to churn. And lastly, remember, it is usually cheaper to retain a player than obtain a new one. Thank you very much.